Hey there, sassy scientist. This is Mrs. Green, and we are doing a unit station identification episode, if you will. So as we play this episode from a really great resource, bozemanscience.com, I am going to stop us periodically to have you write some things down in your notebook. So I'm going to have you pause me right now, get your notebook, get a pen or a pencil ready, and open up to your very next open space. Just start where you left off. Doesn't have to be the beginning of a brand new page, but we may go on to a new page. But we're going to make it work because we're going to use what we have and use space, don't waste in your notebook. All right, should have that notebook ready, pen or pencil in hand. But remember, I'll stop you and prompt you to write some things down. This is a long video, but I'm not going to play the whole thing. I'm just going to hit what I think are some important highlights. I welcome you, though, to go back and view this video. It's a total of 11 minutes, but we're going to, or 11 minutes, 3 seconds. But we're, like I said, we're not going to go quite that long. So let's get rolling with Mr. Bozeman.
Hi, it's Mr. Anderson, and this is Environmental Science Video 3. It's on geology, which is this.
All right, so my bad. His name is Mr. Anderson. All this time, I thought he was Mr. Bozeman. Carry on, though.
More appropriately, how that affects human society. Now, the problem with rocks is that they change slowly. They change over geologic time, and we simply don't live long enough to see all these changes occur. You could imagine how this sandstone is being shaped by the wind, but you can't see it. And it's not until we see lava that we really start to understand the dynamic Earth. And to understand these systems on the Earth, we should really understand how the Earth is put together. And so if we look at the layers, on the inside we have the inner and outer core, we then have the mantle, and finally we have the crust. Now
All right, boys and girls, this is a great simple diagram. I want you to jot that down into your notebook or write it down in that space that you have next up. Pause me if you need to. And moving on.
Live on the crust, and we've only been able to dig just a little bit into the crust. And so we've been able to figure out everything else by looking at how earthquake waves move through the Earth. And we know this, that the crust is made up of rocks and minerals. Rocks are made of...
I do want you to add those diagram words as he adds to it in his lecture here.
Minerals, which in turn are made of molecules and atoms, and they're constantly being reshaped, and we can measure that through the rock.
So there's another diagram or another piece to add to your diagram.
Rock cycle. Now the crust itself is made up of these large continental and oceanic plates, and they float on.
Ooh, yes. Let's add those diagrams or those pieces of the diagram to signify plate tectonics.
The mantle itself. And so this is rock under here, but it's rock that's moving. As we generate heat, as it moves up, it's pushing those plates around. They move very slowly, about the same rate that your fingernails grow, but they have huge force and therefore huge impacts. And so when those plates run into each other,
there's another piece of your diagram.
We have boundaries. An example of that would be the Ring of Fire. So if you look around the Pacific Ocean, you have this area where almost all the earthquakes and volcanoes take place. We also have what are called hotspots, and those are going to be areas where a plate will move over a hot area in the mantle, and we can form islands like Hawaii. Now if we look at where those boundaries occur, we'll have structures like...
Yep, add that piece to your diagram.
Volcanoes and mountain chains, but we also therefore have hazards around those areas where it can impact human society, and we'll discuss a lot of those. And so to understand what's going on the Earth, we should really understand what it looks like on the inside.
This diagram should look familiar. We actually placed this in our notebooks within the last week or so. So you do not have to add this again, but you're more than welcome to pause and add if you like.
So we've got a solid inner core, a liquid outer core, and then we have what's called the mantle. Now, around 85% of the volume of the Earth is going to be in this mantle. And so it's rock, but it's rock that's moving. We're generating a huge amount of heat down here. And then we finally get up to what's called the crust. That's where we live. And so on that crust, we have rocks. And those rocks are constantly being shaped from one into another. And so if we take a look...
This should look really familiar. We've got the rock cycle with sedimentary, metamorphic, and igneous represented. And this was covered pretty well in the last few weeks. But let's take a listen what he says here.
This rock cycle. Since it's a cycle, you could start anywhere. Let's start with an igneous rock. So an igneous rock, like granite, is going to be formed when we have crystallization of magma. So as it crystallizes, you can see those crystals right here. So this granite is made up of minerals. So I can see, for example,
minerals should sound familiar. Are you starting to see, if you haven't already, that science is literally everything connected together?
This quartz and this pink feldspar, and we have this mica. So these are the minerals that make up the rock itself. But this could...
So I sped through a little bit of the rock cycle information, but again, go back and view this video if you would like. You can go to Bozeman Science. It's a YouTube channel. Now I want you to skip a line from that diagram that we copied in a few moments ago. And I want you to write the word convection in big, bold letters. Pause me, and moving on.
But if we get back to the structure of the Earth, what's driving all of this are going to be convection currents within the mantle itself. And so if you look at this and say this is some boiling water, so if we generate a little bit of heat underneath it, that heat is going to be transferred through the water. So if you held your hand up here, you'd feel some of that heat above it. But if we look inside the water itself, we're going to have these convection currents, areas where we're...
Alright, this is a great diagram. I want you to add it below the word convection in your notebook. You can add some color if you want, blue for cool and red or pink for heat. We all know from fire safety lessons that heat rises. And so as the heat rises, it's less dense, that substance is less dense, so it rises. But then as it cools off, it becomes denser, so it sinks. So you can see that rising and sinking motion. Get that diagram in there, and we're going to move on.
Heating it up, and so we're decreasing the density, and then it cools down, and then it's going to sink again. And so we're going to find the same thing in the mantle itself. It doesn't occur as quickly as it does in the boiling water, but it has huge implications on the crust above. And so if we look at that crust, it's actually made up of plates. And so if I trace out a plate like this, this would be a continental plate. And so it's being pushed to the left. And the reason...
Continental plates, those are the plates that are below the crust that we actually live on, the continents.
The reason why it's being pushed is because of this convection current is moving like that. It's forcing the plate in that direction. And it's running into another plate. So we have an oceanic plate.
Alright, so the oceanic plates are underneath the crust that you find underneath or at the floor of the ocean.
Oceanic plates are going to be more dense, and they'll be pushed underneath a continental plate. And what
I want to recap what he said there, and I want you to write this down. Pause me if you need to. The oceanic plates are denser, so they're heavier in a sense. They're going to sink below a continental plate when a continental plate and an oceanic plate collide together. So the oceanic plate is going to sink below.
Going to get right along this margin is going to be a convergent plate boundary. They're running into each other. But we could look over here and maybe there's another oceanic plate that's moving in the other direction. Why is it moving in the other direction? Because the convection current is pushing it here or pushing it there. And so we could have this mid-Atlantic ridge or this mid-oceanic ridge being formed right there. So we've known this for a long time. If you look at the Ring of Fire, we find around the Pacific Ocean we have an aggregation of volcanoes and earthquakes. Something like 75% of all volcanoes, 90% of earthquakes are found in this area. If we start plotting where those earthquakes are, we can start to see where those plates exist. And if we look at the plates on our planet, it's hard to wrap your head around this picture for a second. So this is North America right here, and then it sits on this giant North American plate, and then we'd have the Pacific plate right here. And so those plates are constantly moving around. You're probably familiar with Pangea, which was a time when all the continental plates had come together. So what happens when plates meet is that they can do one of three things. They can slide past one another in this transform boundary. They can move apart. We call that a diverging boundary. Or they could run into each other. That's converging. And so if we look at it...
Alright, so let's go back. I'm going to rewind us just a second here. And I want you to actually place in big bold letters in your notebook. Skip a line in big, and then in big bold letters write plate boundaries. And then right below that, I want you to add those 3 diagrams. We've got a transform boundary here. The plates are sliding back and forth alongside each other, creating a lot of friction. We've got a divergent boundary here. They're pulling apart from each other, so they're creating a rift valley right here. And then we've got convergent boundaries, and these are where the plates are colliding together. Now, some of you might be saying, but yeah, Mrs. Green, we studied this in class. We've got this in our notebook. That's why this video is called a station identification. Okay, a little play on TV words there. Because we will have a test coming up on this subject. And what we know about the brain is that the more repetition, the better our retention and the better and deeper our understanding. So I'm going to stop for there, but again, I highly encourage you to go to Bozeman Science's YouTube channel, check out the rest of this video. Your science teacher will be checking for this information in your science notebook this coming Thursday. That date is October 22nd, and there could be a quiz associated with the information. So that's why it's so key to do these weekly video homework assignments. If you need questions, need help, have questions, we are here for you. You just have to ask. I'm going to sign off for now. Y'all have a great evening, and let's have a wonderful week at Viv Nation.